Good morning, everybody. Welcome to another edition of Lab 207 webcast. My name is Mr. Kite, and I'll be hanging out with you today as we wrap up our series on water. We've been talking about water pollution, so topic for the day is actually going to be water treatment and legislation. As always, let me get you some objectives, and then we'll jump on in. By the end of this video, you should be able to describe the process of sewage and drinking water treatment, and you should be able to explain legislation related to water quality. So, over the last several videos, we've been talking about all of the things that humans do to water or the things that can be in water that harms humans. Today, we're going to talk about ways to clean that up and prevent it. Starting out, we're going to have three processes that you need to know about. You need to know about a septic system, you need to know about sewage treatment and drinking water treatment, and you need to know about the manure lagoon. And then we'll wrap up with legislation that is aimed at protecting water supplies. So, jumping on in and talking about a septic system. Now, first thing you need to know about septic systems is that they're used in areas where people have got fairly large lots of land, because it takes a good amount of land to be able to properly utilize a septic system. And there's a couple of parts of the septic system you need to know about. There's the septic tank and there's the leach field. And I'm going to draw you a little diagram to kind of give you an idea of how this works. So here's our house. The house is putting out wastewater from toilets and sinks and drains and whatever else. This water flows into the septic tank. Now, once the water is in the septic tank, it essentially separates into three layers. Everything that's heavier than the water settles down to the bottom, and this becomes sludge. So there's going to be like solids and heavy particles. Anything that is lighter than water rises up to the top, and that becomes scum. And then you've got your water right here in the middle. Now, all of this sludge down here at the bottom, bacteria and organisms over time will break down that organic material, but every 5 to 10 years, this has to be pumped out. Scum up on the top, again, bacteria is going to break that down. This water flows out into what's called a leach field, which is basically a series of pipes that is underneath the lawn or the ground behind the home. And what happens is water will slowly seep into the pipes in the leach field. These pipes have got little tiny holes in them, and that water will leak out of those little holes into the surrounding ground and grass. The reason that this is beneficial is because the soil microbes and the grass will be able to take up that water, and they will be able to break down any pathogens that are in that water. So any bacteria that might be hanging out, soil microorganisms will take care of them. Also, any extra nutrients like nitrogen and phosphorus, the plants are going to take those up. So it's basically like using nature to do the water filtration. So know that the soil microbes and the plants are going to take this water up and filter it. And then, like I said, this sludge will need to be pumped every 5 to 10 years as the tank fills up. And decomposition by bacteria and organisms takes care of a lot of the waste in your septic tank. So that is a septic system. Now, obviously, in big city areas, people don't have enough land to have a septic tank and a leach field behind their house. And so cities, their best bet is to set up a large-scale sewer treatment plant. I'm just going to kind of walk you through the steps of this. It all starts out with underground pipes carrying waste away from home. So you got your sewer system flowing underneath the streets and houses of the city. And in water treatment, there are usually a couple different treatment levels. We always start out with primary treatment, and then we go to secondary, and then in some cases there will be tertiary treatment. So as our sewage comes in, first thing you do is you've got screens that take out the big debris. This is going to be any really large material that comes in that can be filtered out with a screen. That material will then be carried away to a landfill. After that water has been screened, you get to primary treatment. In primary treatment, you've basically got a big holding lagoon. In this holding lagoon, the water kind of sits still and hangs out for a while. As it sits still, more of the solid waste settles down to the bottom. This is going to be known as sludge. That sludge is going to be collected. It is going to be taken to another facility where water is removed from it. As the water is removed from it, that water is going to go back into the treatment process. The concentrated and dried sludge will be thickened, and then it will be transported away and used as a fertilizer. It could be dried and compressed into fuel pellets. There's a lot of things you can use it for, but that is one destination for the sludge. After the sludge has settled out in primary treatment, that water is going to be passed on over to secondary treatment. In secondary treatment, there is usually a process called aeration. And this is basically where the water is bubbled or air is pumped into the water. The reason that this is done is because this promotes the growth of aerobic bacteria. The reason we want aerobic bacteria is because as they break down waste, they don't make nearly the smell of anaerobic bacteria. So we promote the growth of aerobic bacteria in secondary treatment. They break down a lot more of the organic matter. Anything that's left over, again, is sludge that is collected and it is thickened and processed and then taken away. Once we have finished up secondary treatment, this water is going to be passed on for disinfection. A couple ways that we kill any leftover pathogens is we expose them to the chemicals chlorine or ozone, or you can shine ultraviolet light on them or expose them to chlorine, ozone, and ultraviolet light. Either way, that process will clean the water, take care of any remaining pathogens, and then the water will be pumped out to a large body of water. Now, sometimes this water right here has still got a lot of nitrogen and phosphorus in it, and we don't want to put all those extra nutrients into a big body of water because then you can get an algae bloom like we've already talked about. So in some cases, a water treatment company will run this water through a marsh or something like that. As it runs through the marsh, the plants in the marsh take out the nitrogen and the phosphorus, and the water enters the main body of water nice, clean, and ready to go. So that is sewage treatment. This is drinking water treatment, which is pretty similar, but I'm going to walk you through it so you know. If we are talking about drinking water, we're going to talk about water that's usually taken from a natural body of water. You first screen it to take out any large sticks and twigs and grasses and whatever else. Once it goes through that initial screening, a couple of chemicals get pumped into it. One is potassium permanganate, the other one is a coagulant, and basically what happens is coagulant takes any sediment and stuff and makes it clump together. Those clumps are then big enough that they can settle out in this coagulation chamber, and this sediment right here is going to be taken away and dried and pressed and carried away just like the sludge in our last treatment process. After coagulation, the clean water is taken on and is first treated with chlorine. Chlorine is going to kill a lot of the bacteria and the pathogens in that water. We are then going to filter it again. This time, this water is going to go through a charcoal filter. It's going to travel through sand, it's going to travel through gravel, so it's going to get rid of any further grit, any small sediments, it's going to get rid of any other pathogens. After it's gone through that, we're going to finish disinfecting it. We're going to throw some chlorine into it. That's going to kill any remaining pathogens. We might throw some orthophosphate in it, and then we're going to put fluoride in it to take care of people's teeth. Once it gets to this area, it is now clean, and it can be pumped out into the city water supply for use of all the people in the city. Final water treatment thing, or consideration you need to know about is legal dumping. Now, interesting thing about the way laws are set up around America's water treatment plants. A lot of times stormwater, so that's going to be water that runs into the sewer during a rainstorm, travels through wastewater plants. When you get a big rainstorm and you've got a city going full blast, the water from the rainstorm plus the sewage from the city often overwhelms old water treatment plants. In cases like that, the water treatment plant is legally allowed to dump its raw sewage into the nearest body of water. So this means that if there's a big rainstorm, the gates go open, any raw sewage that is in that water treatment plant flows out with the rest of the water into rivers, lakes, and streams. This makes millions of people sick a year. It's a result of water treatment plants that are out of date or not able to handle the capacity, but be aware that during big rainstorms, water treatment companies are allowed to just dump their waste into big bodies of water. Final water treatment consideration to be aware of is a feedlot and a manure lagoon. So just like when you've got a bunch of people living together producing a ton of waste that has to be dealt with, when you got a bunch of animals living together, same problem. A bunch of cows, chickens, pigs, whatever. If you've got them in a concentrated feeding operation, which we'll talk about in later videos, they produce tons and tons and tons of waste. And the way their waste is dealt with is through manure lagoons. So basically a manure lagoon is a pit that is lined with rubber to prevent leakage. The manure and waste is pumped into this lagoon. As it sits in this lagoon, naturally occurring bacteria is going to break down the waste. Whatever sludge is left over is going to be pumped out and treated and used as fertilizer. This water will then be pushed off to other sources. One of the major problems with feedlots and manure lagoons is two things. One is if there is a crack in the lining on the bottom, all of this wastewater and sewage can seep into your groundwater supply, contaminating it. Obviously, that's a big problem. Another big problem is if there's a huge rainstorm or something like this, all of this sewage in this pond could overflow onto nearby land, homes, farms, whatever. So, two considerations to be aware of with feedlots and manure lagoons. And we're going to wrap up today with a little discussion about legislation. There are two pieces of American water quality legislation you need to know: Clean Water Act and the Safe Drinking Water Act. So the Clean Water Act started out in 1948, was significantly expanded in 1972. Major things you need to know about it is it deals with the chemical, physical, and biological properties of natural water. It deals mostly with surface water, though it's being expanded now to include groundwater. It sets standards for acceptable limits of pollution in waterways. So the EPA will identify problem pollutants. They will say the water can have 10 parts per million or whatever of this pollutant, and then they will monitor the quality of that water. It also gave the EPA power to issue water quality permits and to do water quality monitoring. So before the Clean Water Act, the EPA didn't really have the power to do anything when it came to water quality. Now they do. So the Clean Water Act, know that that is surface waters, acceptable limits of chemicals, and it gives the EPA power to issue water quality permits. Then for our purpose, the Safe Drinking Water Act started in 1974, was expanded in 1986 and 1996. The big thing it did was to establish maximum contaminant levels for 77 different chemicals. Now, for each of those 77 chemicals, there is a limit on the EPA books that says in the drinking water that we have, this is the maximum contaminant level, or the maximum amount of this contaminant that can be present in the water. Contaminants could be biological pathogens, it could be industrial chemicals, could be pesticides, could be whatever. Now, one of the difficult things with the Safe Drinking Water Act is that this list of 77 regulated chemicals is subject to political pressures. So if an industry feels like it's going to cost them too much or to be too difficult for them to lower the amount of a chemical they're putting into waterways, they can lobby the government and get the EPA to set a higher limit that may or may not be safe. So that is a Safe Drinking Water Act. Make sure that you keep it separate from the Clean Water Act. Safe Drinking Water Act is about our drinking water and has maximum contaminant levels. Clean Drinking Water, that is about, or Clean Water Act, that is about surface waters out of doors. Final thing, and as we talk about all the time, there's a major divide between water quality issues in the developing world and in the developed world. We've mentioned before that in the developing world there's about 1 billion people that don't have access to clean water. In industrialized nations, basically the way the process went is as the country industrialized, water got super polluted, people got angry that the water was polluted, legislation and processes were put in place, and the water was cleaned up. In countries that have not yet developed, they are in the stage where they are polluting their water, but they don't have the resources or the political power or a stable government to be able to put legislation and water treatment practices in place. Also, it doesn't help that developed countries often ship our polluting manufacturing off to the developed world, so they deal with the problem of our water pollution and we don't have to deal with it. So be aware that, as with many other things we've talked about in this class, there's a great divide between the developed and the developing world. And with that, I think we're done with our series on water. Thanks for joining us on the Lab 207 webcast. My name is Mr. Kite. Hopefully we'll see you again.